Welcome to the Quark Workbench lab tutorial, which will show you how to use one of the easiest models there is for understanding quarks and how they work together. To begin, let's briefly go over a few definitions. Firstly, quarks. On the most elementary level, quarks are essentially the building blocks of protons and neutrons. There are 6 types or flavors of quarks known as up, down, charm, strange, top, and bottom. Additionally, for every quark, there is an antiquark with the same mass but opposite charge. Secondly, the color force is the fundamental physical force that is responsible for the binding together of quarks. When quarks bind together, they can form other subatomic particles like mesons and baryons. Mesons are subatomic particles that have a mass intermediate to that of the electron and proton. They essentially aid in the strong interaction that binds nucleons together in the atomic nucleus. Baryons, which are subatomic particles like nucleons, have a mass equal to or greater than that of a proton. Now, the purpose of this lab is to show how the different quarks can come together to form mesons, represented by this hexagon, and baryons, represented by this triangle. The idea is to essentially liken the process by which different quarks come together to a puzzle, where different pieces fall into place as a result of patterns and restrictions. For example, here are patterns that work within the restrictions listed on the handout to complete the meson and baryon templates. It is important to notice that it is okay for there to be spaces along the edges that are not filled in with tabs. Additionally, it should be noted that no pieces overlap because there is a space for each tab, just like puzzle pieces that fit together. On the other hand, we have this example of the model put together incorrectly. You can see where the pieces overlap where there is a tab without a space for it, and you can also see that there is an open space on the inside that is not filled with a tab. I said earlier that it is okay for there to be spaces on the outer edges that are unfilled, but when the spaces are on the inside, the puzzle, so to speak, cannot be completed. In the real world, beyond this model, the space on the inside will be detrimental to the functionality of the color force to bind the quarks together to make a viable meson. Alright, now that you know the basics, you can experiment with the different flavors of quarks and see if you can find different patterns that work to fill out the templates and create mesons and baryons. Good luck and have fun!